Ever since we first built sailing ships to cross oceans, our progress as a species has always been tied to the materials we can build with. New materials gave us airplanes to conquer the skies, and then rockets to reach for the moon. But today, well, it feels like we've kind of hit a wall. Our biggest dreams are bigger than the atoms we have to work with. But what if we could just smash right through that wall? Imagine for a second, what if our materials weren't just a little bit better, but literally 100 times stronger than the absolute best steel we have today? And get this, what if that exact same material could also make our electronics 100 times more powerful, all while using way less energy? I know, it sounds like something straight out of science fiction, but it's actually leading to a radical, incredible new vision for humanity. A vision where we don't just explore space, we actually use it to save our home planet. Today, we're going to break down the science behind this amazing possibility. Okay, so let's get into it. This material wall is the real deal. The aluminum and steel alloys that basically built our modern world, we've pushed them to their absolute breaking point. And nowhere is that more obvious than with our biggest dream, becoming a true spacefaring civilization. So check this out. Right now, our space vehicles have a 99.9% reliability rate. That sounds pretty good, right? But as Dr. Reddy points out, that means on the 1,000th trip, someone is probably going to die. You just can't build routine space travel on those odds. And at the very same time, our electronics are hitting their own wall. The silicon transistors in our chips literally can't get much smaller. We're running out of room. But the solution might come from simply rearranging the atoms of one of the most common elements on Earth, carbon. So meet the single-wall carbon nanotube. This whole field is being pioneered by companies like Nopo Nanotechnologies, and their name, Nopo, actually stands for not possible, which tells you everything you need to know about how revolutionary the stuff was once considered. So what is this stuff really? Okay, picture a sheet of carbon atoms, all linked up in a perfect little honeycomb pattern. But the whole sheet is only one single atom thick. That's a material called graphene. Now, imagine you could take that sheet and roll it up into a perfect, seamless tube. That's it. That's a single-wall carbon nanotube. It is a flawless structure at the atomic level. And because it has that perfect structure, it has some absolutely mind-blowing superpowers. Let's start with the one that gets engineers all excited. Its unbelievable, ridiculous strength. A single-wall carbon nanotube has a tensile strength of 127 gigapascals. Now, a gigapascal is a billion pascals, which is a unit of pressure. Look, it's just a ridiculously big number. So let's put it into perspective so you can really feel how big it is. And this chart just says it all. The very best steel we use in rockets and airplanes, that comes in at around 2 GPa. The most advanced top-of-the-line carbon fiber, that gets you to 7.5. And carbon nanotubes, 127. I mean, it's not even a fair fight. This isn't just a little better, it's a completely different league. We are talking about something that is over 100 times stronger than steel. It's a true game changer. And believe it or not, strength is just the beginning. Dr. Reddy calls these the bonus features. CNTs are 6 to 7 times better at conducting heat than copper, which is perfect for getting rid of heat in the vacuum of space. They're also radiation resistant. And this is the cool part. If a high-energy particle comes along and knocks a carbon atom out of place, the structure can literally heal itself. It's pretty much the perfect material for the harsh environment of space. Okay, so let's switch gears for a second. We've talked about physical strength, but what about computational power? Because this material is also set to totally revolutionize electronics. Remember that physical wall silicone was hitting? Well, carbon nanotubes just smash right through it. And this right here shows you just how incredible that breakthrough is. On the most advanced chips in the world today, the little transistor, the switch that does all the work, is about 50 nanometers wide. A single carbon nanotube can do the same job, and it's less than 1 nanometer wide. It's an incredible leap in miniaturization. So what does all that shrinking actually get you? Well, because you can cram so many more of these tiny transistors into the same space, you get a performance jump that is just staggering. We're talking about a phone that's 100 times more powerful than the one in your pocket right now, and it would use way, way less battery. Stronger spaceships and faster computers? I mean, those are amazing advancements on their own. But the true potential here, the real reason this is so exciting, goes way beyond just technology.
It offers a totally new philosophical vision for our future.
This is the ultimate endgame that Dr. Reddy is talking about. The big idea isn't just to find a better material, it's to completely replace the industrial foundation of our entire civilization, metals, with one that's based on carbon. And if you can make your main building block from carbon monoxide, which is all over the place on planets like Mars and Venus, then suddenly you don't need to mine Earth anymore.
And so the roadmap kind of becomes clear. Step 1, you master how to make this stuff on a massive scale. Step 2, you use it to build the lightweight, super safe, and totally reusable space infrastructure we've always dreamed of. And with that in place, step 3, move all of our heavy, dirty industries and all our mining off-world, out to asteroids and other planets. Then, Earth could finally become what it was maybe always meant to be, a protected, beautiful, natural reserve. It's a pretty wild idea, right? It totally flips our usual way of thinking. It suggests that our future in the stars isn't about running away from Earth, but it's actually the only way to truly save it. It really makes you wonder, to preserve our planet, do we first need to build our future somewhere else?